We're joined today in the studio again by your pal and mine, Cody. Cody, wave at the good people. Now, notice this. See, he waved with his right hand, and that's my right hand in there. Put your right hand in there. See? So there are two people here. Proof. All right. So, Cody, I switched out scopes. We got a ham egg here, and this is acting a lot like a Tektronix. It's a much different structure than the old ProTech that we were using. And this guy, I've got my 10 times probe in here, and that means it's attenuating the signal by a factor of 10. Cody, did you ever play old video game systems when you were a kid?
No.
Oh, shoot. Well, I did.
Okay.
When I was a kid, the video game systems that were new are now old.
Okay.
All right. So this is from a Nintendo Entertainment System.
That is old.
The NES. Inside of it, we find a transformer. Okay. I'm gonna plug this sucker in. Cody, this is another one of those things that you should not do at home. I'm gonna plug this sucker in right here. Can you see that, people of the world? World people? Can you guys see that? Yeah. It's plugged in, it's open. All right, I'm gonna take this probe right here, and I'm gonna grab on to this guy. This is connected to the output. Holy cow, Cody, that's a mess. Can you see what that thing's doing?
It's all over.
It's a really, really big mess. So part of our exercise today, Cody, is to try to figure out how to do stuff with an oscilloscope when you just see a mess. Because chances are you go over to a scope and it's not on the right settings. That's annoying.
Yes.
What will you try in order to get us so that we can see a nice sine graph?
Would I try the... Oh, that's the other volt. Okay.
That's channel 2, Cody.
That's not
You're
bad.
a loony.
All right. So this one, channel 1.
Try it.
Okay.
Yeah, what does it read right now? It reads 5 volts.
Okay.
Oh, it doesn't read 5 volts. It reads 5 millivolts. All right, keep going. What are you going to do? What are you going to try?
Maybe.
I mean, you didn't even try it, though. You didn't turn it.
No.
Try turning it.
to the right.
You mean clockwise?
Yes.
But it's all the way clockwise right
Oh,
now.
it
It's not
is.
Whoa, that's a funny
it's
thing.
The bottom.
Yeah, what are you going to do?
I was looking over here for some reason.
It's not
Try
over
turn
there.
it to the left.
Try. Counterclockwise?
Counterclockwise.
Uh-huh. Oh, that seems to be improving. It seems to be improving. Does it? Do you think?
Well, it does.
It looks like lasagna. Lasagna. Ooh, that's interesting. That's a beautiful thing. Now
Okay.
what?
Keep going?
Well, I mean, whatever you want. It seems to be nicely filling the screen. I like that, I guess.
So right there.
Okay.
Maybe.
Yeah, because if you go to the right, it's too big for the screen.
Yeah.
So that's a good size for this particular signal we've got. Yeah, what then what?
And then maybe the red thing.
Well, this guy is a fine adjustment knob, and I actually want to try to keep it locked in one place.
All right.
Otherwise, we won't be able to say. Now, it says 0.5 volts per division. If we move this, then it changes it just slightly, and we don't know exactly what it is. So it has a little bump. Feel that it like locks into position. We don't just have it there so it's not messed around.
Yeah.
This guy right here should probably also be locked into position. That way we can trust those guys. I mean, if we were to use channel 2.
We're not going to do that.
No, golly, no.
All right. Would I try the Y position?
Y position. Try turning that. What happens?
Okay, I'm going to try turning it.
Try turning the Y
clockwise.
position clockwise. Whoop, everything shifts up. And everything shifts down. Put it back in the middle there. All right, that's fine.
Right.
Good to know about that one. What else?
Not that. Let's see. What else can we try?
Yeah, time?
All right.
Sure, time per division. I'm going to adjust this guy back over here so that it's accurately telling us what we should have. And which way are you going to turn the time per division?
I'm going to turn it clockwise.
Sure.
All right.
Is that going to be more time per division or less?
More.
Look at it.
Less. More time per division.
Well, look, if you turn it clockwise, the number's getting bigger or smaller?
Bigger. Oh, smaller.
Yeah, you mean in the smaller
It
sense,
went
yeah.
from 0.1 to 50.
Oh, it's transitioning units
Yeah.
right there. All right, keep going.
Okay, so it's getting smaller.
Yeah, so less time per division. You're taking even less time per division, less time per division, less time per division.
It's not looking
wow,
good.
no.
Right.
We've got a signal that's slower than what you thought it was
Let's try
initially.
turn it to the left.
More time per division.
Counterclockwise.
Oh. Whoa.
No, that's
Where do you want to be, man? Where do you want to be?
I want to be right here.
I kind of like that right there. Now, this is kind of weird. It's doing some kind of weird triggering. I'm just going to move this so that I can get it so it stops triggering that way. I'm going to trigger off of the line. And then we've got that. Yeah, that's pretty good. Now, another thing we could do is we can change the focus. Like, sometimes when you turn on a scope, it looks all nasty like that.
Okay.
And you could actually focusing a beam of light so that it is focused at focusing the electrons so that it's that beam looks good. And you can change the intensity. If it's too bright like that, that's jarring. Nobody
Yeah.
likes that, especially on,
Hurts my eyes.
on a Wednesday. No, turn it down a little bit, like that. If it gets too dim, though, we could turn it back up. Turn it up, you know what I mean?
I know.
Okay, I want to know everything about that signal. I want to know, for instance, the amplitude and the frequency. Go, tell me what you're thinking.
Okay. Frequency
Yeah?
would be 1 over period.
Frequency is 1 over period. I like it, I like
Okay.
it.
And the period is between 2 high or 2 low points.
Frequency is between 2 high points or 2 low points. I agree with you so far. Go ahead.
So we could find frequency by...
Wait, like between 2 troughs, you mean? Like from here? Let's draw on here what we think is the period. From right there to right there, that's what you're saying is the period?
Yeah.
Uh-huh, I guess I agree with that. That's a period. You know what might be an even better way to measure the period?
What?
To get 2 of them. What if we go from here to here? That's
Okay.
2 times the period. And then we could calculate the period from that.
Okay.
And then we could take the inverse of it to get the frequency.
Okay.
All right? So, can you get me the period from what you see right there?
The period. So if each one of these boxes
Good.
is 50 microseconds.
See where the dot is right there? This is the action line right there.
I keep looking at this one for some reason.
Oh, well, that one doesn't have a white line on it, so it's no good.
I have no idea why I'm looking at that. Okay, so 5 milliseconds.
5 milliseconds, go ahead.
So if each one of these boxes is 5 milliseconds.
Oh, okay, you're cool.
Okay. Why does it do that?
I don't know. It's a
Okay.
sensitive circuit.
All right.
Don't get your hand near here, you get electrocuted.
Okay, I won't do that. Maybe. Then from this line to this line would be 5, 10, 15, 20, 25, 30. Almost 35.
Counting by 5s is fun, but I think it might be better to just get how many divisions we have, and then we can multiply it out.
Okay.
I mean, I agree that you probably get right in the almost thing, though. But
Yeah.
the best way to do it, I think, is to say, this is just slightly to the right of that. You know what we can actually do? We can shift this. See, it says X position? We can shift it until it's exactly in the center right there. There. Now we got 1 box, 2 boxes, 3 boxes, 4 boxes, 5 boxes, 6 boxes, 6 point what? Give me your best estimate of how many boxes that is.
7.5.
2 times the period is 6.75 boxes. See, I wrote that down for you. 2 times the period is 6.75 boxes.
Okay.
So, 1 period then is how many boxes? 6.75 divided by 2.
Yeah.
Okay, and then I'm supposed to multiply that by how many volts per division?
You're supposed to multiply that by 5
how many milliseconds. We're talking
Yeah.
about time.
Oh.
I'm so sorry.
volts. Wait, are we talking about time?
We
or-
are talking about time.
We're talking about time.
Sorry.
So 5 milliseconds.
5 milliseconds per division.
division,
Okay,
yeah.
so I've got 3.375, and I'm going to multiply that by 5 milliseconds, and I get 16.875 milliseconds. Oh my gosh. Sorry, internet people. 16.875, let's call it 16.8 milliseconds. 16.8 milliseconds, and that is, I'm about to say the inverse of that sucker. I'm going to take 1 divided by 0.0168. You know what I'm saying?
Mm-hmm.
Guess what? Can you read that?
60.
Tell those good people. It says 59.5, right?
Yeah.
59.5 is really close to 60. What are you thinking about this Nintendo Entertainment System? What's it putting out?
60 volts.
Units.
60.
60 frequency units.
Okay.
How do you measure frequency? How do you measure how often something happens? You hit your hammer on your thumb. Hurts, don't it?
Yeah, a little bit.
Mm-hmm. Ow.
Hertz.
Oh, hertz! 60, oh, yeah, 60 hertz. All right, so we're talking about 60 hertz. Let's read this thing right here. It says Nintendo Entertainment System output AC 9 volts. Well, let's see about this 9 volts contention right here. We have found that the frequency is 59.5 hertz.
Okay.
Which is probably 60. It's probably supposed to be 60, and guess what? That's what our wall's doing here in America. That's the way we roll. Now,
Okay.
we're trying to find the amplitude, too. Go.
Amplitude.
Amplitude.
So, amplitude is from midline to the bottom of the well.
True. Or midline to the top.
Yeah.
But what if instead we got twice the amplitude?
So all the way from the top to the bottom.
Yeah. That would be 2 times A, right?
That would be.
So another nice thing we can do is we already know about the time basis, so let's bring this in right here, and then we can just say, let's bring it way out here again. Remember we had it out here and we weren't triggering right? We were triggering like this. We made like a bulk line and we went like that. There, the lasagna. I'm saying that we can best get peak to peak like this.
Yeah.
And what would be even more interesting is what if I just raised this or lowered it? Because I don't care because I'm getting twice the amplitude.
Yeah.
What if I raised or lowered it? Where am I doing this? Y position?
Yeah.
Go ahead.
Okay.
Raise it or lower it until the bottom is at one of these lines. Maybe not the midpoint, but a little lower, like that one right where. We're going to take that one. That'll work, sure. Right in the center, we're measuring that. So how many boxes do we have to get twice the amplitude?
1 box, 2 box, 3 box, 4 box, 0.4.
4.4 boxes, I think that's a perfect estimate. 4.4 boxes equals twice the amplitude. What's the amplitude there, Cody?
The amplitude is volts is 0.5, so do we have to multiply 4.4 times 0.5?
4.4 times 0.5 will give you twice the amplitude.
And then divide by 2.
Absolutely. So, can you do it all in your head? Do you want to?
In my head?
Well, why not, right?
4.4 times 0.5 would be 2.2.
Mm-hmm.
And then 2.2 divided by 2 would be 1.1.
1.1 volts. But I read that box and it said 9 volts. 1.1 volts. And I read the box and it said 9 volts. What the heck?
I don't know.
You forgot the 10 times probe! That's like a land war in Asia! So, we're going to multiply that by 10. We're going to say that the amplitude is 11 volts. And what's interesting is they promised us that we'd have an output of, 9 volts?
Yeah.
But I don't know if they were talking about peak to peak. It's possible that they were talking about RMS value. So I'll take 11 volts, which was our calculated amplitude, and divide it by the square root of 2. There we go. And I get 7.78 volts. Seems like if they were trying to get 9 volts, they didn't do quite such a great job. Yeah. And the old ProTech that we were using. And this guy, I've got my 10 times probe in here. And that means it's attenuating the signal by a factor of 10. Cody, did you ever play old video game systems when you were a kid?
No.
Oh, shoot. Well, I did.
Okay.
When I was a kid, the video game systems that were new are now old.
Okay.
All right. So this is from a Nintendo Entertainment System.
That is old.
The NES. Inside of it, we find a transformer. Okay. I'm going to plug this sucker in. Cody, this is another one of those things that you should not do at home. I'm going to plug this sucker in right here. Can you see that, people of the world? World people? Can you guys see that? Yeah. It's plugged in. It's open. All right. I'm going to take this probe right here, and I'm going to grab on to this guy. This is connected to the output. Holy cow, Cody, that's a mess. Can you see what that thing's doing?
All over.
It's a really, really big mess. So part of our exercise today, Cody, is to try to figure out how to do stuff with an oscilloscope when you just see a mess. Because chances are you go over to a scope and it's not on the right settings. That's annoying.
Yes.
What will you try in order to get us so that we can see a nice sine graph?
Would I try that's the other volt. Okay.
That's channel 2, Cody.
That's not
You're
bad.
a loony.
All right. So this one, channel 1.
Try it.
Okay.
Yeah, what does it read right now? It reads 5 volts.
Okay.
Oh, it doesn't read 5 volts. It reads 5 millivolts. All right, keep going. What are you going to do? What are you going to try?
Maybe.
I mean, you didn't even try it, though. You didn't turn it.
No.
Try turning it
to the right.
We're joined today in the studio again by your pal and mine, Cody. Cody, wave at the good people. Now, notice this. See, he waved with his right hand, and that's my right hand in there. Put your right hand in there. See? So there are 2 people here. Proof. All right. So, Cody, I switched out scopes. We got a ham egg here, and this is acting a lot like a Tektronix. It's a much different structure than